In this section, we will go through how to interpret an infrared spectrum, and we'll cover the key regions of the infrared spectrum that you, as a student of pharmacy, need to know. So here is an infrared spectrum for hexane. Now, on this infrared spectrum, I'm going to overlay the sections of the region that you need to know about and the functional groups that you need to remember. Now, this is the absolute minimum that you need to know to interpret an infrared spectrum. Now, first of all, we have the region to the left of the spectrum. So this is the region between 3000 and 3600 wave numbers. Now, in this region, you will find groups such as the OH group, NH, NH2, and in rare cases, you'll have a CH group of a terminal alkyne, and we'll be looking at that in more detail in the next section. Now, you also need to know the region between 2000 and 2400 wave numbers. This is where you can find groups that contain triple bonds. So, for example, carbon-carbon triple bonds in the form of alkynes, and carbon-nitrogen triple bonds in the form of nitrile groups. The third region that you need to know about contains double bonds. So these are carbon-oxygen and carbon-nitrogen double bonds, and spans the region of the infrared spectrum between 1550 and 1750 wave numbers. Groups in this region include esters, ketones, aldehydes, carboxylic acids, amides, and nitro groups. Now, the final region that you need to know about is the fingerprint region. This is the region below 1500 wave numbers and can be seen here. This region you only need to know about because you don't need to use it. So it's not useful for identification of functional groups because you tend to get a lot of vibrations within this region. So you need to know where these three regions lie in the infrared spectrum and which functional groups will give absorbances within those regions. But for the fingerprint region, you simply need to know that you don't need to use it. Now, I'm going to demonstrate to you that based on that information, you already have enough information to answer a 5-mark exam question. So this is a question from a past paper. So in this question, you are told that a student isolates 3 impurities from a pharmaceutical formulation, and these are the compounds given here, so compound 1, 2, and 3. They realise that the compounds contain a nitrile group, which is here, alcohol, or ketone functional group, which means that you can differentiate them using infrared spectroscopy. So where would you expect the characteristic absorbance by the nitrile group in compound 1 to appear in the infrared spectrum? And this will get you 1 mark. Well, we must return to the 4 key areas in the infrared spectrum. So we have this region here between 3000 and 3600 wave numbers, where we find OH, NH, and NH2 groups, and in rare cases, the CH of a terminal alkyne. We also have this region here where we have triple bonds, so this containing alkynes and nitriles, and this is between 2000 and 2400 wave numbers. Now this corresponds to our nitrile group here. Now if we bring in the rest of the spectrum, we have our third region, which contains carbon-oxygen and nitrogen-oxygen double bonds. We have esters, ketones, aldehydes, carboxylic acids, amides, and nitro groups present within this region. And then finally we have the fingerprint region. So what we can see is that the nitrile group matches up with this region here between 2000 and 2400 wave numbers. And so if we saw a peak in this region, we would know that compound 1 would have to be the nitrile compound. So let's look at the next part of the question. Which compound, 2 or 3, they're shown here, one with an alcohol, one with a carbon-oxygen double bond, so we have a ketone, give rise to spectrum A? And explain your answer by specifying which is the characteristic signal for the functional group in this molecule. And this gives you 2 marks. And then you're asked to do the same for spectrum B, which is here. So what we have is two molecules, one with an alcohol functional group and one with a carbonyl functional group. Now, remembering back to the previous slide, we would expect an alcohol to absorb between 3000 and 3600 wave numbers, and we would expect a carbonyl to absorb at between 1550 and 1750 wave numbers. So, can we match these up to the spectra? Well, an alcohol group gives an absorbance between 3000 and 3600 wave numbers, which can be seen in spectrum A. So we can see this absorbance here. Now the carbon-oxygen double bond will give an absorbance in the carbonyl region of between 1550 and 1750 wave numbers, and is therefore present in spectrum B. So the way that you would answer this question is you can explain that which functional group belongs to which spectrum, and you can give the specific absorbance for those functional groups that lets you tell the difference between the two. So again, this is the minimum that you need to know to be able to identify compounds using infrared spectroscopy. So we have the region between 3000 and 3600 wave numbers that contains OH, NH and NH2 groups, and in rare cases the CH of a terminal alkyne. We have between 2000 and 2400 wave numbers, the region containing carbon-carbon and carbon-nitrogen triple bonds, and between 1550 and 1750 wave numbers, the region containing carbon-oxygen and nitrogen-oxygen double bonds. And this gives us the functional groups of ester, ketone, aldehyde, carboxylic acid, amide, and nitro groups. And then finally, below 1500 wave numbers, we have the fingerprint region. Now this is not useful for visual identification of functional groups, and I'm going to show you why that is. So here is the fingerprint region for two compounds. We have beta-methazone and dexamethasone. Now the only difference between the two compounds is that we have a methyl group pointing in opposite directions. So these compounds are very, very closely related to each other. Now what we can see is that the fingerprint regions for the two compounds contain a lot of peaks, but that these peaks are very different to each other. So even though we have the same compound with the same functional groups, we have compounds with a different spatial arrangement of atoms. And we're not able to use infrared spectroscopy to distinguish between these two molecules. So this fingerprint region ends up with a lot of absorption peaks, and it makes it very hard for us to work out what is going on.